Discord. I'll remember streaming here first. My screen is visible. Yeah.
Yes.
So let's start discussion starters 166. One by one, I'll just share what the problem is and what the approach is. Hmm, किसी का लोड हो रहा है नेट
Yeah, it's working for me.
होता है और फिर सेम थिंग हाँ खुल गया चलो so yeah the first question states there is a library and for each return book returned late the penalty is the number of days the book was overdue. If multiple books are returned on the same day, only the highest penalty is counted. Okay, this is the main thing. And now you're given n books. The ith book was I days late. It was returned on day AI. Okay. Now you just have to like the input is given like this. You have to find the total penalty chef must pay. So, so let's say it was this. So this is the array given is day returned and the penalty for each person for each book penalty is 1, 2, 3, 4, 5, 6. Now what is happening is these two books are getting returned on day one. Penalty, what is the maximum among these? It is 2. So my penalty mein I add 2. Same thing for all the books returned at day 2. What is the maximum penalty? It is 4. Same thing for all the books at which is this. So you do plus 6. Your cost is 12 over here. Now how do I do this? It is simple. This value is I plus 1. Now since I'm going in from 1 to n, what I can do is I can store a map of the day and the penalty. Map or a vector, either or work. Vector, yeah, vector will, vector, yeah, might work. Yeah. But map is just easier. So what we do for this is like, yeah, you just store this map. You iterate over all I from 1 to n. Wherever I get a day, I just store the penalty with that. Let's say previous penalty was X. Now I have some same thing with a penalty Y. This is gonna be greater because I'm going it like increasing order. So just store the penalty directly. I don't need to take the max every time. And yeah, that is the thing. I'll just show you the code. I have a map. So I go from 1 to n inclusive. I store the value directly and my sum is just all the penalties together. That's it. Any doubts? No? Good.
Mm.
Good. So let's move on to distinct power. Distinct power, yeah. So the way I solved it, it is kind of weird, kind of guesswork. There might be a better proof, like a proof behind it, but if anyone else has it, let me know. I'll tell you how I solved it. Okay. So you're given ancient powers, you're given A of like array of integers where AI represents the power of the ith troop and all powers are distinct. Now, firstly, you rank all of these and you get the array B. Now, what you need to do is you remove exactly one troop from the array. When a troop is removed, the remaining troops are re-ranked from 1 to n minus 1 based on their powers. Like, find the number of distinct ranks arrays possible. In simpler terms, how many different arrays of these size n minus 1 you can get after removing one troop and re-ranking the troops. Okay. Main thing, like I'll tell you like how it goes, and then I'll move on to work. Okay, so these are the powers given in the input. This is basically input. Now rank after ranking, what is the array? It is 2, 1, 3, 4, 5. Okay, this is after re-rank. Okay. Now what the question is stating, if I'm removing this, what is my new array? My new array becomes 4, 3, 1, 2. What you're doing is whatever value you've removed, I just subtract the greater numbers by 1. Okay, this is removing 2. Okay, same thing. If I remove 5, I get 2, 3, 1, 3, 2, 4, 1, 3. If I remove 4, I get 2, 4, 1, 3. If I remove 1, I get 1, 4, 3, 2. And if I remove the last 3, I get 2, 4, 3, 1. Okay. Now what you see over here is these two arrays are same. Okay. All the others are distinct. So my answer over here is 4, which is the answer over here as well. But actually I got the proof. Yeah. So like one observation which you get directly from here is 5 and 4, they were together. If I remove 4, they're resulting to the same thing. So what is happening is 5 minus 4. What is the value? 1. That is why they're same. What is 2 minus 5 is not 1. 4 minus 1 is not 1. 1 minus 3 is not 1. Like absolute value. So since it's 1, I'm reducing this because this is gonna lead to the same thing. And what is happening is, let's say I have some values here, some values here, and I have an x here, I have a y here. Okay. And what I'm saying is, let's say x plus 1 equals y. If I'm removing x, this value and this value, if let's say I'm removing, wait, that is it. If I'm removing x, these values will become something. Okay. If I'm removing y, these values will become something. But what my proof is, let's say I'm removing x. How many values get changed? All the values from x plus 1 to n get changed. They get changed to x comma n minus 1. Correct? Yes, no? Hello.
Yes.
Huh. So when I removing x, these values change to this. And what is x plus 1? It is y. So what is happening is this entire thing is becoming like y becomes x. Yeah. And now let's say I'm removing y. Remove y. What will happen? X plus 2 to n get changed to x plus 1 to n. Correct? So yeah, x plus 2 to n become x plus 1 to n. And instead of y, what is there on its place? X is there on its place, correct? X is on y's place, and over here, instead of x, x is only there. So, like, what is happening is, if I have x and y, if I remove x, if I remove y, these two different, this array and this array is gonna be same. If x plus 1 equals y, since these two are together, and I'm removing anything, doesn't really change my entire array. So my answer for both of them is same. Does it make sense? Is it like clear to you? Hello. I can share it with an example also, but yeah. Basically, if I have an x and y where the absolute difference is x minus y equals 1, so they'll lead to the same array. So I do answer minus minus and initialize my answer with n because my answer can at most be n. Does it make sense? You can type it in chat, anything. Cool. I guess this makes sense. So yeah, that is it. Submissions. So I do the exact same thing which I explained from this. So I put the array in a set so that I can rank it. I get the rank for each value and then I re-rank the AI. Now I have an answer. If the difference is 1, then I subtract 1. Subtract the answer. That's it. Literal same thing. Does it make sense? This part is a very standard technique called coordinate compression or re-ranking. So if you don't know this, do read it up. It is a very powerful technique to solve a lot of questions. Cool. So yeah, let's move on to costly permutations. Okay. So costly permutation, basically the value vi, there's a permutation, okay, of length n. The value vi is the number of steps needed to return to index I following this path. Start at index I, let current index be k, move to pk, continue till you return index n to index n. Basically, if you're at 1, no, index 3, I go to 5, then I go to 1, then I go to 3. Since I started at 3, I end there. So what is the cost? It is basically 3 over here. Cool. 3 or the number of, like, yeah, 3. Now what chef can do is perform operations, modification operations, such that I can swap I comma j. Co- Cost of the swap is vi plus vj. And after swapping, vi the value of vi and vj change because my permutation is changing. Now my goal is to transfer the permutation to achieve the maximum possible sum of all values vi. Find the minimal total cost to achieve this maximal possible value. Okay. So it's a very complicated statement that has three, four different parts. I'll break down everything individually. Okay. Hmm. 2, 3, 1, 4, 5, 6. Okay. Let this be my permutation. Yeah. So what is happening? Let's say, like, let's calculate the VI. Okay. Firstly, VI, what is happening? Let's say I'm starting at index 1. 1 goes to 2, 2 goes to 3, 3 goes to 1. Now the main thing is, so what is the cost for 2? Cost for 2 is 3. Okay. What will be the cost for 3? Same thing, no? It's basically a cycle. So from whichever point I start at, the cost is going to be the size of the cycle. So for 2, 3, and 1, the answer is 3 only. Okay, and let's just not 4, 5, 6, 5, 6, 7, 4. Okay. Now what is happening over here? 5 to 6, 6 to 7, 7 to 4, and 4 to 5. Okay, so what is this? It's a size 4 cycle, and all the elements will just get this value. Does this value part make sense? How will I calculate it? How will I calculate it? I'll just start, like, how will I calculate it? I'll come to later, but this is what the value is. Does it make sense? Yes, no?
Yes.
Yeah. So now my question is, so this is the first part. The second part is modification. Let's not come to the modification first. My goal is to transform the array into maximum possible sum of all values. What is the maximum value every person can have? Every index can have just 7, 7, 7, 7, 7, 7, 7. Correct? What does this mean? All of them are part of a one giant cycle. Correct?
Yes.
Yeah. So this is the case. All part of one cycle. So now what does the problem become? Problem becomes from from X cycles, I need to make one cycle. Correct? This is the key observation. Okay? I'll have different number of cycles. Okay. Over here there are two. There can be like there's a let's say hundreds different cycles. Okay. I need to do some operations to make it one cycle. Now let's come to the operation. What is happening is I choose two indices, I swap them. Let's not come to the cost first, but I swap the values at the permutation values, not the VI. I'm changing PI. Okay, I'm changing the PI value, swapping the PI values, and yeah. So how do like I'm swapping the PI values? How do I merge two cycles? Okay, over here I have two different cycles. Okay, I want to make it one. With this operation, how will I merge? Let's just see. Let's say I swap 1 and 5. What does my array become? My array becomes 2, 3, 5, 1, 6, 7, 4. Correct. Now let's calculate the cycle for this. 2 to 3, 3 to 5, like 1 to 2, 2 to 3, 3 to 5, 5 to 6, 6 to 7, 7 to 4, and 4 to 1. Damn. By just one swap, I'm able to like merge two cycles. Does it make sense? Can you see this?
Yes.
Yeah. So basically, my thing is with one operation, I merge two cycles. Okay. What is the cost? It is Vi plus Vj. In one cycle, the Vi value is constant, right? In both the cycles, any index I swap, the Vi value is going to be the same, correct?
Yes.
So if I'm merging two, my cost will be what will be my cost? Wait, cost equals size of cycle one plus size of cycle two, correct? Now let's come back to the main question. From X cycles, I need to make one. Since the cost is dependent on the size of the two cycles, why won't I always take the minimum two sizes and merge them? Does it make sense?
Yes.
And my wait, size of new cycle equals size of cycle 1 plus size of cycle 2. So I got the new size and I have the cost. I keep doing this. I keep merging the two cycles till I have one cycle. Make sense?
Yes.
Yeah. So how do I implement this? How do I code this up? That is a main thing. So now that is where I combine all these things together. Okay. Now let's copy this so that you can see. Yeah. So I firstly taken the input, leave the priority queue first. I'm making a visited array because let's say I've computed 231 is one cycle. Do I need to calculate for 3 and 1 separately? No. So if I visited 3, I won't compute for 3 once again. So that is why I need the visited array for all indices 1 to n. If it's already visited, I continue, or else I start my operation. I start my this basically code where j equals I, count is 0. Count is basically size of the cycle, and I make the jth index visited. I increase the count because I've added one node, and j becomes p of j. While j not equal to I just go. So I from 1 I go to 2, 2 I go to 3, 3 I go to 1. And when I've reached 1, I stop. Okay. So whatever count I have is the count for this particular cycle. I just push it to the priority queue. I'll have X different cycles. All of them will be stored in the priority queue. Now, while the priority queue size is greater than 1, I'll get the first minimum and second minimum. Priority queue basically in login query gives me the first minimum. So I get the first minimum, I remove it from the priority queue. Then I get the next minimum, I remove it from the priority queue. Answer becomes first plus second, and the new cycle is basically first plus second. Make sense?
Yes.
Yeah, so that is it. That is the entire code. So yeah, this question is more of a reading question. So if you read it properly and you deduce every single step, what is a cycle, what is the main goal, and how do I merge two cycles, then you can solve it. So this is a structured format to solve any question. If you have many different parts to it, solve each and every part, and then try to combine everything together. And then you'll basically able to code it out. Okay. Now coming to the devices array, I'll talk about easy version and hard version separately because in Div 1 to a lot of people who did easy did hard, but in the other divisions there is a very sharp decrease between easy and hard. Right. Very few people who did easy did hard. So that is very important to know. So yeah. So I'll come to easy version. I'll break down all the steps and then I'll tell you how to optimize the answer for the hard version. Technically, the optimization is completely different, but yeah, I'll give you the ideas. Okay. Don't worry. So yeah, firstly, you're given an array A and an M. I'll create BI such that BI is AI into M factorial. Okay. Now, what I need to do is for each element B, I calculate f of BI, where f of x is the number of factors of x, number of divisors of x, or factors of x, whatever. Now, some key observations. Let's have 1, 2, 3, 4, 5, 6. Okay. This is my array, and m equals 100. What is 100 factorial? It is 157, 10 raised to 57, 157, sorry, which is very huge. So if people were thinking, like some people, like obviously in the starting, I also thought, hey, why don't I directly make BI and then calculate the factors? Isn't it pretty straightforward? But since M is 100, this M factor only is too big. How will I store this M factorial? And then how will I calculate divisors? Because a
We
very
are taking mod, so like, does
uh,
it
yeah,
matter?
I'll talk about that. Yeah. So firstly, divisors. Does anyone know how to calculate the number of divisors in like a very brute way? O of n you can do. Basically check for every number 1 to n if it divides. Yes.
Yeah, or else in square root of n.
Yes. And the optimization to this is you convert it into root n. And how do you do this? It's you just go from one like I into I less than n basically. Property of factors. I won't deep down into that basics. If you want me to talk about it, I will. But yeah, I assume you know. If you don't, you can just read it up online. But yeah, there is a uh, algorithm to calculate in square root of n. Now, can I calculate for 10 raised to 157? What is square root of this? 10 raised to 80, approximate 10 raised to 80. 10 raised to 8 I can do. 10 raised to 80 is just huge. So even I can't do this. Yeah. And one more thing, even if I like this, even if I were able to store this value, I can't calculate the divisors only because it's too big. Now one more thing. Now since I can't store it, they're telling me to do it modulo 1e9 plus 7. And modulo just breaks everything. Why does it break everything? Let's take, I'm taking 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my modulo, correct? Mod equals this. Let's say AI equals 1, 2, 3, 4, 5, 6, 7, 8, 2. What will my AI mod be? Just 1, correct? Because it's just one plus the mod. So this is gonna be 1. What are the factors of this? 2 is a factor of this, but is 2 a factor of 1? No, right? So basically, this is how we prove that after taking mod, I can't directly just calculate the factors. It just loses all meaning. Does it make sense?
Yes.
Yes.
Yep. So now, how do I calculate these factors? That is the main thing. So there is a very like it is a well-known thing, but if you don't know, I also didn't know around 6 months ago. But there's a property. If you just Google it up, number of factors of a number. If you just Google uh, formula factors of a number, you should just Google, and it will tell you number of factors is this thingy. What is this? I'll explain. Let's say I have a number 130. Okay. What this algorithm does is, firstly, I'll prime factorize 130. Okay. Prime factorize 130 to how many times is it divisible by 2? 130, 75, 65. So it's only once. Not divisible by 3, divisible by 5. So you have 30 once. Let's not give 130. Let's put 330. So this becomes 165. Then for 3, I have 55. Array, this is also. Let's just make it 260. Simple. 130, 65, 13, and 1. So prime factorization basically gives me it is 2 raised to 2 into 5 raised to 1 into 11 raised to 1. Correct? This is the prime factorization of 260. Make sense?
Yes.
Yeah. So this basically is it a theorem? I don't know the name of the theorem, but yeah. So the number of factors is basically all the powers you see over here. You just multiply power plus 1, like each and every power. So the number of factors for this will be 2 plus 1 into 1 plus 1 into 1 plus 1. Okay, which is 2 into 2 into 3, which is 12. So there are exactly 12 factors. You can verify this from this. If you, I just, you can just verify this. But yeah, this is a very well-known theorem. And yeah, now if you also want product of factors, it is n raised to total factors by 2. So yeah,
Hello.
that is, yeah, hello.
What's the name of the theorem?
I don't know. Like, in GFG, it's not given. Number of factors, CP, um,
This comes in aptitude, I think.
yeah, aptitude fields. But I don't. Literally no clue of what the theorem is, but yeah. So basically, if I can, now my question is, now my thing is, if I can prime factorize, then easy to calculate. Correct? It's just product. Fair? How do I prime factorize this number? AI into M factorial. So main thing to note here is, since M factorial is 100, I can, wait, there's also one more thing. Let's say I have A and I have B, A into B. If I want to calculate the number of factors, if I want to calculate the number of factors, I don't multiply A into B. Let's say I get this as X. I get the prime factorization for this, and then I convert this, and then I get the number of factors. I don't need to do this. What I can do is I have PF of A. I'll have prime factorization of B. I can just add these things. Why is it the case? Let's just take this example of 4 into 6. Okay. What is the prime factorization for 4? It is just 2 raised to 2. This is 2 raised to 1 into 3 raised to 1. What is happening to the powers of when I'm taking 2 as common, it becomes 2 raised to 2 plus 1 into 3 raised to 1. This is standard exponentiation, multiplication with exponentiation. Yeah, wait. Sneha, can you just mute because my echo is coming? Yeah, okay, cool. So this is why you just add the two different prime factorizations. I don't need to multiply and then get the prime factorization. Okay. Why am I doing this? Calculating for AI is easy. Okay, how do I calculate for AI? There is this thing like you can just search it up into like integer factorization only. You have this um, this thing. There is formats factorization, but pre-computed primes. There is this algorithm to get the prime factorization. And instead of this also, wait, isn't there the huh? This is it. There's also a different way to do this, which just works in n log n, basically log n for any number. And yeah, how do I do this? I'll tell you. Let's say I have a number n. Okay, number n has let's say 2, 3 times, 3, 4 times. Then a big prime, let's say 1e9 plus 7, 10 times. Okay. To calculate this, not one, this is too big. Just give me a prime 31. 31 is 10 times, 3 is 4 times, 2 is 3 times. Okay. What do you do in your normal prime factorization? I get the smallest prime and then I divide, correct? If I'm doing it manually, do I do the same thing? I get the smallest prime, let's say it's 2, then I divide. Then let's say the smallest prime is 3, then I divide. And I do that, right? Correct? Yes, no.
Yes.
Yes.
Yeah. So if I have for every number from 1 to 105, I store smallest prime number. Then can I just directly hop on directly like I just hop. Correct? I don't need to calculate the next prime. Yes, no.
Yes.
Yeah. So if I store this, then I can basically then my task of prime factorizing any number, I can do it in log n, log base 2 of n. Like it's not log base 2 also, it's close to this. Like if there are higher powers, it's easier, it's faster. If all of them are twos, then it's slower. So the worst case is log 2n, but yeah, average case it might be very high, very low. Okay. So now that is why I said I can factorize AI very easily. Cool. I'll come to
Yes.
how do you calculate SPF later. That I'll explain with code only, but a code and diagram. But yeah, understood कि AI का calculation I can do very easily. Yes,
Yeah.
no. Yeah. So
Prime
now how do I
factorization.
calculate for m factorial? I can do the same process for AI, but I can just do this for 1, then 2, then 3, then 4. Only thing I need to do this is if after I've calculated 4, I copy this to 5 and then I add the powers of 5. Does it make sense? Let's say 4 ka what is the prime factors? No wait. 2 ka prime factors is 2 raised to 1. 3 ke prime factors mein I copy this. 2 has only one power and I add 3 ka prime factorization. For 4 I copy this. I have 2 as 1, 3 as 1. And now what is the prime factorization of 4? 2 raised to. So I just add this up. Correct? So I just have 3 over here. And let's repeat this process till 100. Okay. And since 100 is a very small number, there are only 25 primes up to this point. So you can do this copying, you can do this prime factoring very easily. Okay.
Okay.
Hmm. So now what do I have? Now I have prime factorization of m factorial. I have prime factorization of AI. Now calculate factors of AI into m factorial. How do I do this? I add these two up and then I use this formula. Right. Very good. Hmm. I use this one. Okay, make sense? Hello.
Yes.
Yes.
Yeah, I can do this for every AI, and it won't. I like it won't tell you, and I'll tell you the time complexity later. Okay. Now, for prime factorization of AI or any prime factorization, now I need the smallest prime factor. Okay. How do I do this? Very like a very straightforward thing. It comes from the idea of sieve of Eratosthenes. You can read about it, but let's say I have these numbers. Okay. One has two, two has two. Now all the multiples of two will have its smallest prime factors as two only, no? Make sense?
Yes.
For three, all the multiples which are not multiples of two will have this value as three. And yeah, I won't calculate for four because four has a different smallest prime factor. And this is how you calculate. And this happens in n log n. Okay. So yeah, I'll just come to the code because I guess that's all the different parts to the code, parts to the question. I'll explain. If do you have any doubts in this entire steps? So what do I do? Firstly, pre-compute PF of m factorial. Then for each I calculate prime factorization. Then I add PF of AI plus PF of m factorial, and then I count factors. Okay, these are my steps. Make sense?
Yes.
Yeah. So let's come to the code. Yeah. This I have with me already. Array, I had updated this. I'll just copy paste. Yeah. So now, firstly, how do I calculate smallest prime factor? I initialize it as a 1e5 array. N is 1e5 maximum. Mod I'll come to later. But now, firstly, all the numbers I'll assign their smallest prime factor as themselves. Firstly, 4 will have 4, 5 will have 5, 6 will have 6. Okay. Then for all numbers, if my smallest prime factor is myself, that means I am a prime number. And since I'm a prime number, I go on for every multiple of the number and I just store SPF of j as SPF of j, min of SPF of j, comma I. That's it. I've calculated smallest prime factors for every number from 1 to 1. Make sense? Then, then I have to calculate. Then what is my step? I have done this. Wait. SPF I calculate, which is done. Now I need to calculate for every m factorial. I store this vector of maps in prime factor of 101 because that's the maximum size. From I2 to 101, what do? I copy the previous map, then I factorize the current number. And what does the factorization function do? While n is greater than 1, I just update the current map, okay? जो current map पे SPF of n का position है. SP of n is smallest prime factor of n. So in that position in the map, I just increment 1 and I divide n by SPF. Simple. This is the entire factorized code. Make sense? Hello. No, no.
Yes.
Yeah. So now what is done? This is done. Now I need to calculate for each AI. So what do I do? Firstly, I'll take this is what prime factorization of m factorial. Cool. Whatever the map is, I store it. I copy this entire map because instead of adding, isn't my factorize function adding it directly? Since my factorization function is adding directly, I just copy it completely and I just pass it to the factorize function. You do whatever you want. You just add all the current factors of AI. After I've got the prime factorization, I count factors. How do I count factors? For every prime number, whatever its frequency is, plus one I add and I multiply with the answer, the current answer. Answer is gonna be one earlier. And yeah, that's it. I print the answer. Simple. Does it make sense? Yes, no.
Yes.
Cool. So yeah, that is it. That is how you get AC in the easy version of the problem. Now the hard version. Yeah. Now the hard version, the only difference is AI is up to 10 raised to 7, M is up to 10 raised to 7. Now, what is the problem with our approach? What is the problem with the code we did earlier? Wait, I'll just show the code also. What is the problem with this entire part? This will give TLE. What is the problem? Hello.
M
That
factorial.
calculation.
M बहुत बड़ा है.
M बहुत बड़ा है and I'm copying this entire previous one, no? Copying में I take O of n time. मतलब जितना भी time, जितने भी factors है. 1E7 तक there are lots of factors. So I can't just keep copying every single time. No, it will take a lot of time. Since 100 तक factors only 25 है, copying 25 values is very easy. But copying 1000, 10,000 values for every single step is very hard. It takes time. So this entire thing will give TLE. Simple as that. Okay. So easy version, I can't do this. I'll have to come up with something better. Okay. So what is a better method? In M factorial, what I'm doing for pre-computation, I am doing 1 to M, पूरा का पूरा. Correct? I'm storing 1 ka value, I'm storing 2 ka value, I'm storing 3 ka value. And then I'm getting M ka value. Correct? But now I can't do that. So what is a better way to do this? Now what is M factorial? It is 1 into 2 into 3 into 4 into 5, so on till n. Correct? Now, the main thing is let's just see this. Okay, wait. Where have I drawn this? Yeah. Okay. This is the prime factorization for m factorial. This is 2 factorial, 3 factorial, 4 factorial, 5 factorial. Okay. What do you see here? First thing you notice, if 2 is existing pehle, okay, and 4 is also there, my contribution, like 2 will have one, at least one time it'll be there existing at 5. Like all the prime factors before 5 will be there in there. Correct? All of them. Because it's just multiplication of all, right? If I have 10, so 3 will be there, 2 will be there, 5 will be there, 7 will be there in my prime factorization of m factorial. Correct? Yep.
Yes.
Now, how do I calculate this value for 2? Is my question. I have 2, 3, 5, 7, 11. Okay. But how do I calculate the values for each? Now, main thing to note here is 2 will be present in each of its factors up till m. Correct?
Yes.
Yes.
So जितने भी factors है, like how many multiples of 2 will be there from 1 to m? It will
Well,
be m by 2, right? Correct?
yes.
Huh. So if I am at 5, what is 5 by 2? 2. Cool. What is 5 by 3? It is 1. 5 by 5 is 1. This is 0. This is 0. Make sense?
Yes.
But now there's a problem. I have a 3 over here. I need a 3. And I have a 2. What is the problem?
4.
I'm not calculating for 4. And the same thing I won't calculate for 8, 16, 32, 128, all the powers of 2. So then what do I do is, I also calculate 5 by 4. I also calculate, wait. So my, basically for 2, for any number p, okay, my answer is gonna be m by p plus m by, wait, let me just confirm this. थोड़ा सा, हाँ, m by p square plus m by p cubed, so on. Does this make sense? Hello.
Yes. Yeah. Like this was the formula.
हाँ, like formula नहीं, you can just see ना कि 2 कितनी बार आ रहा है. 2 will come m by 2 times. Then 4 कितनी बार आ रहा है? Because 4 I'm missing out, right? The number of times 4 will occur is m by 4. Number of times 8 will occur is m by 8. Correct?
Yes. ये फ्लोर होगा ना?
हाँ, floor. अरे wait, seal लिख दिया. हाँ, floor. Sorry. Yeah. So this for every prime number. Correct?
Yes.
Yeah, cool. So this is how I can calculate for m factorial. But now I still have a problem. I'll just show you the code for m factorial. So I have stored all the primes, okay? All the primes overall. If my current prime is greater, that means I can't have it in m factorial, right? Make sense?
मतलब उसका तो 0 हो जाएगा तो
हाँ,
कंप्यूट करने का कोई
उसका
सेंस नहीं।
contribution कुछ आएगा नहीं. Correct. Now my current answer, like the number of times the prime factor will be there, like the frequency of it, will be, I'll start from j equals p. Count is actually not necessary. And I just keep multiplying j p times till it is less than equal to p. And I just add the m by j. Simple.
Yes.
Make sense?
Yes.
Huh. And then the prime factorization basically becomes Prime factorization P is just the answer, whatever you calculated. Correct?
Yes.
And now one more thing. Let's say I've calculated for 2. Okay, let's say there are 5. Can I update my number of factors directly? Because number of factors is P plus 1 into Q plus 1 into R plus 1. P is basically 2 raised to P, Q is basically 3 raised to Q, and R is basically 5 raised to R. Pakad. Like it can be any prime number, and you just go on. Since I've calculated for 2, I can just update this, no? Correct. I can
Yes.
make factors equals, like, I can just update it. So that is what I'm doing. Why am I updating it? I'll talk about it abhi. So now, our original solution, wait, easy wala. Where is it? Huh. Over here, for AI, what am I doing? For every AI, I'm copying the prime factorization of M. Correct? In this step, I'm copying the entire prime factorization. Can I do it for this? Can I copy this entire prime factorization for every AI? The answer is no, because there can be 1000 primes. And if there are 1000 primes and my n is 1e5, what is 1000 into 1e5? 1e9. This is too big. Correct? Hello.
Yeah.
Yeah.
Yes.
So that is why if you see over here, like in my submissions, I got a TLE here. I did the same thing if you want to see. I calculated the prime factors, then I store it in a map, I factorize, and then I calculate the answer. Even this step is too big, and copying is also too big. Like copying actually kind of like it's faster, but iterating over all factors will give TLE for sure. Correct?
Yes.
Huh. So now what do I do? Main observation. Abhi, let's say I have m factorial as 2 raised to, like, I'll take this only for example. 2 raised to 311. Okay. This is my prime factorization. Now let's say I have AI equals 4. What is getting updated?
2.
2 is only getting updated. No, it is going from 3, it is becoming 5. Correct? Yes, no?
Yes.
Huh. So what is the number of factors for this? It is 4 into 2 into 2. What is the number of factors of AI into m factorial? It is 6 into 2 into 2. So what can I do? Can I just divide this by 4 and then multiply by 6? Is the same thing, right?
Yes.
Yeah, so that's what you do. So for every prime factor of AI, if you see over here, I factorize AI and I only factorize AI, okay? I'm not multiplying with m factorial, and I'm only considering the primes of AI. I'll come to the complexity later, okay? Then what do I do? Whatever the prime factorization in the m factorial was, I'll have to divide. Here it was 3 plus 1. So the whatever the 3 is plus 1, correct? I divide and then I multiply previous prime factor plus current prime factor plus 1, correct? So 6
Yes.
is basically 3 plus 2 plus 1, right? Yes, no?
Yes.
So yeah, that's all you do. And you get the answer. But yeah, one thing to note, everything is modular, so you can't directly divide. Okay. I am doing some trickery such that I can divide. What is the trickery? I am using a mod template. This mod template basically handles everything for me. I don't need to do per modulo mod every single time. In divide, usually take inverse of the divisor thing, but this struct basically handles everything. It inverts it and then multiplies. Okay, so that is why if you see in this, I'm taking mod since I didn't use the template, and here since I'm dividing, I use the template, and the code just becomes cleaner. Correct. So now some more modifications. Now SPF becomes 1 is 7 because now my AI can have values of 1 is 7, and I also store primes. Now, how do I store the primes? Since I know all the SPF of I equals I will be prime, I just push back directly. I don't think about anything else. Simple. Yes, no. Hello. Yeah. So now, yeah, what is the complexity? How many different prime factors can a number have? A number which is 1 is 7. How many different factors it can have? Let's just see, na. What is the minimum? Like, what will I do? 2 into 3 into 5 into 7. Let's say all of them are only one power. Okay. See how big the number is growing. Then 17, then 19. Already 1, 2, 3, 4, 5, 6. This is already 96. If I multiply it with 23, this exceeds the AI, right? So this will never occur in the prime factorization. So what is the maximum number of primes I can have? 1, 2, 3, 4, 5, 6, 7, 8. Only 8 different prime factors I can have. Make sense?
Yes.
So since there are only 8 different prime factors, I can iterate over them easily. Okay. Same goes like this will have a lot of prime factors, but this won't. Okay. So the complexity for this part of code is O of n log n. This is for factorization plus 8. Wait. O of n into log n plus 8. Okay. This is basically factorization, which factorization is happening in log n, and 8 is for iterating. And even this inversion also has log n, so you can also add a log n here. But yeah, modular division. Okay. So this part basically just comes out to be n log n. Now, what is this part? How many prime numbers are there? I'll just print. Okay. See out prime dot size. These many prime numbers. 1, 2, 3, 4, 5. 65. I'm worst case, I'm iterating over all prime factors. So let's take m equals 65 for my time complexity, not m, p. Okay, my time complexity becomes p into what is this entire path? This entire sums up to log n. Okay, so here I have log m. Okay, here it is m because it is bounded by the size of m, not p. So this is p log m and 65 into log 2 of 27 is 1, 2, 3, 4, 5, 6, 7, which is 1e7. So this is 1e7. This is 1e5 into log n, no? Log ai, which is log 2, 1e7. This is 1, 2, 3, 4, 5, 6. This is 2e6. So my overall complexity is what? This. And this entire thing is also actually log n and log. And this is 1e7 log 2n. There is faster ways to do this, but this is probably too big. 1, 2, 3, 4, 5, 6, 7, 8. 2e7, 2e8, but time limit is 3 seconds, so it will suffice. Make sense? Yes, sir.
Yes.
Good. And yeah, if you're wondering the time complexity for the easy version, this entire part is it's just n log n only approximately. So don't like doesn't really matter what you're doing. It's approximate n log n. Cool. And since it's 1e5, it will fit in 1 second, or else it doesn't fit in 1 second. Cool.
Yeah.
Any other
The mod
doubts?
template that you have shown,
Yes.
does it also handle a non-prime module?
Not really. Like the inversion thingy, like this entire part,
Yes.
relies on P being prime.
Okay.
If P is not prime, it will give a runtime error. Like M is not prime, it will give a runtime error because of this assert. So yeah, you have to be careful for this. If you're not dividing, then it will work. But if you are dividing, then it won't work. That is the main takeaway. Cool.
Okay.
And if you want this template, you can just search up Cactal modular arithmetic. No, no, spelling doesn't matter. So yeah, this is the exact template. It also includes this Euclid.h, so you also copy this part. So yeah, so that is why if you see, I have this struct mod and I've also copied this Euclid. I've copied this, like copy pasted this entire thing. It's a template. You can use it. Okay, works.
Yeah. Thanks. Yeah.
Cool. So I guess bye bye stream, bye YouTube, like, comment, join Discord. To see you the next